The main thing that we have to understand is the data warehouse schemas. What is a schema? In data warehouse, a schema is used to define the way to organize the system with all the database entities like facts, dimensions, measures, grains, and their logical association with each other. Talking about a data warehouse schema, there are few important points that we have to understand. Mainly, what is a grain, what is a fact, what is a dimension, and what is a measure. After understanding these points, we will deep dive into the types of data warehouse schemas, which are mainly star schema, snowflake schema, and fact constellation schema. So without wasting time, let's move ahead guys to understand what is a grain. So friends, a grain is basically a pivotal step in a dimensional design. The grain is the lowest level which we can look or identify in a database. The grain establishes exactly what a single fact table represents. The grain declaration becomes a binding contract on the design. The grain must be declared before choosing dimensions or facts because every candidate dimension or fact must be consistent with the grain. This consistency enforces a uniformity on all dimensional designs that is critical to BI application performance and ease of use. Atomic grain refers to the lowest level at which data is captured by a given business process. Normally, we strongly encourage you to start by focusing on atomic grain data because it withstands the assault of unpredictable user queries. Rolled up summary grains are important for performance tuning, but they presuppose the business's common questions. Each proposed fact table grain results in a separate physical table. Different grains must not be mixed in the same fact table. So friends, what is a grain? A grain is basically the lowest level that we can see in a fact table. And what is a fact table? And what is a dimension table? There are two main tables in any data warehouse system, a fact table and a dimension table. What is a dimension table? Dimensions provide the who, what, where, when, why, and how context surrounding any business process event. Dimension table contains the descriptive attributes. I would like to re-emphasize friends, dimension tables contain the descriptive attributes used by the BI applications for filtering and grouping the facts. Again, used by the BI applications for filtering and grouping the facts. With the grain of a fact table firmly in mind, all the possible dimensions can be easily identified. Whenever possible, a dimension should be single valued when associated with a given fact. Dimension tables are sometimes called the soul of the data warehouse. Why? Because they contain the entry points and descriptive labels that enable the data warehouse or a BI system to be leveraged for business analysis. A disproportionate amount of effort is put into the data governance and development of dimension tables because they are the drivers of the user's BI experience. Friends, just to make you understand, in any table, we would normally come across two kinds of data. One is the theoretical, or you can say the descriptive data, and one is the factual data. The descriptive data we put inside the dimension tables. Okay. Then what do we do with the non-descriptive data that we call the factual data? That data goes inside a fact. And that is why facts are the measures that result from a business process event and are almost always numeric. Please focus guys, and are almost always numeric. A single fact table row has a one-to-one relationship to a measurement event as described by the fact table's grain. Thus, a fact table corresponds to a physical observable event and not to the demands of a particular report. Within a fact table, only facts consistent with the declared grain are allowed. For example, in retail sales transaction, the quantity of a product sold and its extended price are good facts, whereas the store manager's salary is disallowed, even though it is numeric. Okay? Even though it is numeric. So we have to understand that what we have to consider as a fact and what we do not have to consider. Facts contain the numeric measures of the business. They contain facts. Facts and dimensions are connected to each other. Two type of columns, facts or measures, and foreign keys to dimension tables. So guys, what actually is there in a fact table? In a fact table, we will find two things. Either we will find facts or we will find the foreign keys which are relating them to the dimension tables. We will come to this topic in our subsequent sessions when we will understand how fact and dimension tables are connected to each other. The fact tables may contain date stamp data. That is also very much possible. A fact table might contain either detail level facts or facts that have been aggregated. So very much possible. What does it mean? For example, it might contain the number of units being sold in a particular day. That is an aggregated data. For example, on Monday, the number of units sold were 20. On Tuesday, it is 30. Okay, so all this is an aggregated data, and we can have individual data also in a fact table, right? Like the price of a car, okay, the price of a model, okay. So these individual values are also available. So it all depends how we are using the fact tables. The last but not the least is the measures. Measures can be qualitative like a product ID or quantitative like the price of a product. As I said, it can be qualitative like a product ID or quantitative like the price of a product. These details about the fact is called a measure. Okay, remember guys, what is a fact table? Combination of foreign key and measures. What is a measure? This is a measure. Part of data modeling is applying calculations or aggregations to quantitative measures as necessary for the data model. The qualitative measures can be then linked to specific characteristics of the measures which are called dimensions. So friends, I hope we are able to draw an imaginary line where we are moving from measure inside a fact through a foreign key inside a dimension table. So this is how the traversing between facts and dimension tables actually happen. We have types of measures also. What are the types of measures? Additive, measures that can be added across all dimensions. Semi-additive, measures that can be added across few dimensions and not with others. Non-additive means measures that cannot be added across all dimensions. So guys, I think these few concepts makes the understanding more clearer, and we can deep dive into other components. One more important component is the examples of dimension, fact and measure. So here this is an example of one of the schema, and in this I would like to emphasize that this is a sales table and we are considering it as a fact table, and it is surrounded by dimension tables called product, organization, time and location. Friends, please try to understand what is there inside a dimension table. First, we will have a primary key. In this, we are saying that a dimension table is having a primary key called product dimension identifier in the bracket PK. PK stands for primary key. And look at the kind of data we are having. Names, category names, subcategory names, feature description, timestamp. Remember what we covered in what is a dimension, what kind of data it will have. It will have the descriptive data, the theoretical data, the non-factual data. And friends, look what is there inside this sales fact table. Sales fact table is very much full of the foreign keys, because fact table is a combination of foreign key and measures. So we have 4 foreign keys because this fact table is connected to 4 dimension tables. One is time dimension identifier, which is connected to time dimension, location dimension identifier, which is connected to location dimension, product dimension identifier connected to product dimension, and organization dimension identifier linked to organization dimension. And after that we have 2 measures. One is the sales dollar and one is the date timestamp. So friends, this is an example how a schema basically looks like, and how a fact table looks like, and how a measure looks like. I hope it made things a bit more clearer. Let's move ahead, guys. Another component in data warehousing is cube. What is a cube? Cube basically contains a set of data that is usually constructed from a subset of a data warehouse and is organized and summarized into a multi-dimensional structure defined by a set of dimensions and measures. Friends, what happens is that sometimes client not only wants to see the BI reports because there is a limitation to the BI reports. The limitation is those BI reports are 2D, they are two-dimensional. But what if we want to go three-dimensional? In three-dimensional, we want to go into using the cubes. And what are cubes? They are organized on subsets of data in such a way that they are multi-dimensional structures defined by a set of dimensions and measures. And if you all can correlate what I'm saying, guys, we all are interested in two things: dimensions and measures. Dimensions means the name of the product, measures means the number of units of the product has been sold, and how they are connected through each other: the primary key in the dimension table and the foreign key in the fact table. So guys, we have SSAS OLAP cube. What is SSAS? Equals SQL Server Analysis Services, and here it is showing an example of an OLAP cube. So guys, we can see it is three dimension. Okay, we can see measurements or the measures, they are written in one side. We can see time dimensions like product model, product code, cell phone pager. We have dimensions like east, central, west, and then we have sub dimensions like restaurant, Dallas, Houston, San Jose, Boulder. So friends, what happens? We can roll up and roll down. So these are different kind of techniques that we will that we can use while moving inside or moving outside the cubes. It is a bit high level, friends. As and when required, we can go into the details in subsequent sessions. Otherwise, this much would be more than enough. What are the advantages of these SAS cubes? SAS cubes are fast and provide cube setup on very huge volume of data. The calculated measures are fast execution wise and easily reusable. They are defined centrally in the SAS database, and reports pick and choose the calculated measures as and when required. So friends, cubes are also very necessary into this setup. Now going forward, I think we have covered a lot of details about basic setups, and now we can deep dive into the three main type of data warehouse schemas we have. Number one is the star schema. Star schema is perhaps the simplest data warehouse schema, and it is called a star schema because the entity relationship diagram of this schema resembles a star, which means points radiating from a central table. The center of the star consists of a large fact table, and the points of the star are the dimension tables. Something like this, friends. So this is an example of a star schema, and we all can see that this is a fact table sitting in the center and its other points radiating like a star as dimension tables. So here is a fact table called property, and these are the dimension tables called time, branch, promotion, owner, staff, buyer, as well as property. So friends, what is there in a fact table? I would again like to reiterate foreign keys and facts. So we have how many dimension tables? 1, 2, 3, 4, 5, 6, 7. So we have the 7 foreign keys which are connecting this fact table to this dimension tables: 1, 2, 3, 4, 5, 6, 7. And we have some facts also like offer price, selling price, sale commission, sale revenue. And look at what kind of dimension data we are having: day, week, month, type, city, province, promotion, name, type, name, position, gender, name, type, city, province, type, street, city, country, postcode. So friends, I think the previous example that we covered, that was also a star schema, and this is also a star schema. So I think it is very much clearly understandable. Each dimension in a star schema is represented with only one dimension table. Friends, please note it down. Each dimension in a star schema is represented with only one dimension table. The dimension table contains the set of attributes which I just read it out. There is a fact table at the center. It contains the keys to each of 4 dimensions, which are the foreign keys. The fact table also contains the attributes, namely dollars sold, units sold, in this case offer price, selling price, sale commission, and sale revenue. Please note one thing, friends. Each dimension has only one dimension table and each table holds a set of attributes. This is a key point when we are talking about a star schema. Please have a closer look, friends. And now we can move on to the next type of schema of our data warehouse, that is Snowflake schema. So first of all, Snowflake schema and the Snowflake course are two different things. Snowflake schema is the schema of a data warehouse and Snowflake is the name of the data cloud tool that we are going to cover in our future sessions. So they both are not at all linked to each other in any way. Snowflake schema is basically a variant of the star schema where dimension tables contain normalized data. Now what is a normalized data? Friends, if I am combining the data into a one big table, we are normalizing it. And when we are breaking data from one table into different tables called fact and dimension tables, we are denormalizing. This is just a very high level discrepancy I can explain you between normalized and denormalized data. For example, city and provinces can be splitted as separate tables to normalize dimension tables. Snowflake schema is a hybrid structure that contains a mixture of star and snowflake schemas. This allows dimension tables to be present in both forms for different query requirements. This is how a snowflake schema actually looks like. And we have one fact table called property sale and we have a dimension table called branch, and we can say that a dimension table is then normalized into city and province table. Okay, it is normalized with city and province table, and again fact table having those foreign keys and dimension table having its dimension and primary keys. Some dimension tables in the Snowflake schema are normalized. Friends, please be aware, some are normalized. It is not necessary that we normalize all of them. The normalization splits up the data into additional tables. Unlike star schema, the dimensions table in a Snowflake schema are normalized. So this is the key differentiation between a star schema and a Snowflake schema. Due to normalization in the Snowflake schema, the redundancy is reduced and therefore it becomes comparatively easy to maintain and save the storage space. So guys, this is about our Snowflake schema. Going ahead, we have a fact constellation schema, which is basically a combination of your star schema and Snowflake schema, and sometimes we call it fact constellation schema, sometimes we call it galaxy schema. So in the diagram below, it can be seen that it's basically a combination of both. We have multiple fact tables and we have multiple dimension tables. As you can see, we have this fact table, sales fact table, we have shipping fact table, then we have multiple dimension table like time, item, branch, location and shipper. The sales fact table is same as in the star schema. The shipping fact table has the 5 dimensions, namely item key, time key, shipper key from location to location. The shipping fact table also contains 2 measures, namely dollars sold and units sold. It is very much possible to share dimensions between fact tables. For example, time item and location dimension tables are shared between the sales and shipping fact. What we are trying to say, that it is also possible to share the dimension tables between fact tables. For example, time item and location. So where is this time? Time dimension table and location dimension table. This time dimension table sales is shared with the sales fact table, and also this location dimension table is also shared with the sales fact table. So here we have 2 foreign keys, one is for the time table and one is for the location table. It is very much possible in the fact constellation schema. So guys, these are the schemas that we have in a data warehouse, and after this we will deep dive into more topics which will better our Snowflake curriculum. Thank you guys. Best of luck.